Hello everyone, myself Aryan Dakre. I am from CSE Data Science Department of JD College of Engineering and Management. So today we are going to explore one of the most fundamental algorithm in machine learning, K nearest neighbor, and especially how it's used a powerful classification approach for image recognition. So let's go on slide 2. So what is image recognition? As its core, it's about teaching computers to see and interrupt the world like we do. It's the process of converting the raw data of an image, essentially just a grid of pixels, into a meaningful understanding. A key part of this is classification, the task of assigning a label like cat to an entire image. This is the problem that KNN help us to solve, as I have shown you in our image. So let's go on to the slide 3. The core idea behind KNN is beautifully simple. Simple similarity is proximity. It assumes that things with similar features will exist in close proximity to one another. KNN is a lazy algorithm. Instead of learning a complex model from a training set, it just stores all the labeled data. When a new unknown data point appears, like these gray stars, these are the gray stars, KNN walks up and does its work. It looks at the k closest neighbor to the new point. If we choose k equals to 3, it finds the 3 data points near to our star. In this case, two algorithms are orange square and one is a blue circle. Through a simple majority vote, the orange square wins. And just like that, our new data point is classified as an orange square. It's the entity. So as we can see in this image, the similarity is proximity. So let's move on to the fourth slide. So how does this apply to image? It's a clear three-step workflow. Step 1 is feature extraction. And image is not a simple data point, so we first need to convert it into a numerical feature vector, a list of number that the algorithm can understand. This could be as simple as the raw pixel value. So the steps 2 is to find neighbors. The feature vector of our new image is then compared to every single feature vector in our stored label dataset. The algorithm calculates the distance between them to find the k most similar image. And then step 3 is majority vote. The algorithm looks at the labels of those k neighbors and assign the most common label to our new image. If 4 of the 5 nearest neighbor are the 8 digit, our image confidently classified as an 8. So let's move on to the fifth slide. Of course, KNN has its own pros and cons. Its biggest advantage are its simplicity and the fact that no real training phase makes it very easy to implement. However, its advantages are significant. It can be very slow during prediction because it has to compare a new image to every stored image. It also requires a lot of memory to hold the entire dataset and can be very sensitive to irrelevant features or noisy data. So let's see its real world application. Despite its limitations, KNN is used in several real world applications. It's a classical method of handwritten digit recognize. It can be used in medical analysis to classify cells, and its principles are even applied in recommendation systems to find similar item for you to buy. So let's go to the final slide. So to conclude, what are the key takeaways? First, KNN is a simple and highly intuitive algorithm. Second, it classifies new data based on the principle of similarity or nearness. And finally, while more complex model exists, KNN remains a crucial foundational algorithm for anyone learning about machine learning and data science.